Good morning. Today is 18th November 2020. The day is Wednesday. My name is Ferhan Mazher, and right now I am with the 10 metric class. We are studying physics of the 10 metric, and today we are going to start and we are going to study the few topics from the chapter number 16. From the chapter number 16 out of your book, we will be studying only those concepts which are included in the new syllabus. Okay? The first thing which you should understand is the digital and the analog. Digital and analog. Are the spellings correct? Analog is written like this?
Yes.
Yeah? Okay. So, digital and analog, you must have heard it. For example, if you see this clock, this wall clock, this is an analog clock. And we can also get a digital clock which will show display. For example, so basically, analog are those quantities when you draw their graphs, the value of that quantity will change continuously. For example, analog something is graph. If you draw and the value is changing, the graph will be something like this. Okay? The value is continuously changing with the smoothness. If something is digital, its value do not change like this. Its values will be changing abruptly. For example, like this. For example, like this. Like this. If you draw a graph between the digital and the analog, that will be something like this. Digital, because we are going to study the basic electronics, in the digital, you know what happens, we have only two, we call them states, and that is 1 and 0. The values can be either 1 or it could be 0. It's a story, okay, just learn it. The values in the digital electronics can only be 1 or it can be 0. 1 means we say it's hot, sometimes we say it is cold. We say it is on and this means off. Okay? You understand? In the digital electronics, there will be only two things, 1 and 0. For example, let me show you a very good example. So, for example, suppose I have a lamp, or you can say for example, for understanding, let's say this is a lamp, and here I have a switch, and it is connected with the battery. So this is battery, this is a switch, and this is the lamp. So let's say I write here switch and I write here lamp. If this switch is open, I will say it's 0. The lamp will be off. Obviously it will be off. If the switch is open, the part of the circuit is not completed, then the lamp will be also off. The lamp will not give light. So it will be also 0. If you close this switch, the switch becomes, in English we say the switch is hot. So the switch is on. What will happen with the lamp? The lamp will also start giving out light. So the lamp will also become hot. Understand? Okay. Now learn another thing. Suppose we have, I have, let's say, two lamps. and I have two lamps and I connect them in, for example, okay. For example, here I have a lamp and it is connected with, here I have a lamp. This is switch number 1, this is switch number 2. Very simple. It's connected with the battery, switch number 1, switch number 2 and a lamp. And where is your copy? Okay. So suppose this is switch number 1, switch number 2, this is lamp. If the switch number 1 is open, switch number 2 is also open, what do you think will happen with the lamp? Will the lamp give light? Will the lamp give light? No. So the lamp will be also off. Okay. Now close switch number 1. Switch number 2 still open. Can the lamp be also on? No. The path of the current will be not yet completed. Okay. Let's keep the S1 open and close the S2. Close this S2. Can the lamp be switched on?
No.
No. Because it is open. It's still off. Okay. So suppose you close the switch 1. Suppose you close switch number 2. Now what will happen with the lamp? If you close both the switches, then the path of the current will be completed. If you close both the switches, the path of the current will be completed and the lamp will switch on. Understand? Okay. Let's consider another example. Now, suppose I have switch number 1. Let me call switch number 1. Oh, this is switch number 2. And here we have a lamp. Is connected with a battery. Now, let's see what happens here. Switch number 1, switch number 2, and the lamp. Okay. Now, if both are open, like this, the current cannot reach the lamp. So the lamp will be off also. So if this is open, the lamp will be off. Okay. If I close this one, but I keep the S2 open, see what will happen. If I close this one, the path of the current will be completed and the lamp will be switched on. Although this is open. Now, open this one, close S2. So the path of the current from here will be completed. Okay, so the lamp will switch on. Understand? Because the path of the current is complete. This is open, this is closed. So from here the current can flow through the lamp and come back and the lamp will be on. Now, close both of them. S1, S2. If you close both of them, still the path of the, if this is closed, this is also closed, the path of the current will be completed, lamp will be on. Understand what I'm saying? Okay. Let's do another thing. Now, suppose I have a lamp here. We have, this is another situation. Here is switch number 1. Now, suppose this is lamp. Switch number 1 and the lamp. If this switch is open, the current will flow through the lamp, come back, so the lamp will be on. If you close it, this path will have less resistance. The current light that path which has less resistance. So what will happen? The current will flow from here in this loop and come back. It will not go into the lamp because this path will have less resistance. So if you close the S1, the lamp will become off. Okay. Try to understand everything. From here. If I tell you, I get this result by multiplying S1 and S2, I get the result. Will I be wrong?
No.
You see, 0 multiplies 0, 0, 1 multiplies 0, 0, 0 multiplies 1, 0, 1 multiplies 1. Okay. Look what happened here. If I tell you that I got this result, we got this result by logic. But there is another way also, that I got this result by adding them. I will be not wrong. And I am talking about the binary, this is binary, which has only two digits, 0 and 1. Binary mathematics we say. 0 plus 0, 0. 1 plus 0, 1. 0 plus 1. 1 plus 1 is 2, so that's 1. In binary, there is only two digits, 1 and 0, so 2 means 1. Okay. Here, whatever is S1, you invert it and you get the answer. In what means to reverse whatever that is. So for example, if the S1 is 0, inverse it, revert, invert, flip it, change it. 0 means change here, 1, and 1 means change it, 0. You understand? Do you understand?
Yes.
Understand? Okay, now this is multiplication, this is addition, and this is no, this was just for understanding. Okay. Hot and cold. Yeah. I was just trying to tell you that. Okay. Now we are moving to the next thing. Next lesson. We have logic gates. And just you need to understand what their truth tables. Logic gates are basically, for example, the first logic gate is AND. Try to remember this thing. AND. The AND in the circuits, electronic circuits, the AND will be represented something like this. They will make a D. It will have two inputs and an output. Let me say the input is A, the input is B, and the output is X. Okay? A, B, X. What I am writing is called truth table. This is called truth table. Okay? So, the X which you got here is equals to A multiply B, and this is the circuit symbol. So this could be, there could be four options. The A can be 0, B can be 0, A can be 0, B can be 1, A can be 1 and the B can be 0, and the both can be 1. So what will be the result? AND is like multiplying. Okay? AND is like multiplying. You multiply them. 0 multiply 0? 0. 0 multiply 1? 1. 1 multiply 0? 1. 1 multiply 1? That will be 1. So, open, off. So, sorry. 0 multiply 1, that is 0. 1 multiply 0, that's also 0. Sorry, I made a mistake. I told you that you have to multiply. If you multiply 0 with 1, the answer is 0. This is the truth table of the AND gate, and this comes in paper to make. The thing you have to remember is that there are two inputs A and B, and the output is X. How you get X? By multiplying A and B. Very simple. Okay. Another gate we have, we call it OR gate. OR gate, and that is something like this, like a spearhead. Some people represent it with a triangle, and it has two inputs A and B. The output is X, and A, B, and the X is equals to A plus B. This is Boolean algebra. We call this mathematics Boolean algebra. Okay, so you don't need to go into the details, but this is Boolean algebra. Okay. So there could be four possibilities. Okay. So the value of the A can be 0, 0. This can be 0 and 1. This can be 1 and 0 and 1, 1. So these are the possible combinations of outputs. The output, how we get that output? By adding them. 0 plus 0, that will be 0. And 0 plus 1, that will be 1. 1 plus 0, that will be 1. 1 plus 1, 2, and the Boolean algebra, that is still 1. This is OR gate. We have another gate, we call it NOT gate. That is called NOT gate. It is represented perfectly with a triangle, and on this vertex of the triangle we put a circle. It has a single input, and we have the output. So from here, in the NOT gate, the output is actually, you invert whatever is the input. You reverse whatever is the input. Okay? So for example, you can have the input can be 0. If the input will be 0 and when you will invert it, reverse it, it will become 1. If the input is 1, you invert it and the thing will become 0. This is called NOT gate. Okay. We have another gate that is a combination of two gates, that is called NAND gate. What is called? NAND. N-A-N-D. This is AND and NOT gate. Okay? It's normally represented like this. There are two inputs, A and B. Then it is fed to a NOT gate, and then you get your final output. This is normally represented in a single diagram also. We represent it like, put a circle here. These both diagrams are used to represent the NAND gate, meaning AND gate and NOT gate. Okay? So if I will draw its truth table, here I will have A, then I will have B, then I will have X. And the X will be A multiply B and then invert it. Okay? Because whatever is the output of the AND gate, that is fed to a NOT gate. So it could be 0, 0, it could be 0 and 1, it could be 1 and 0, it could be 1 and 1. So how I get the truth table for the NAND gate? Try to understand. You multiply them, whatever the answer you get, then you invert it. Inverter. So 0 multiply 0, what will be the answer? Then invert it. 0 multiply 1 will be 0. When you will invert the 0, the answer will be 1. 1 multiply 0, the answer will be 0. And you invert it, it will become 1. 1 multiply 1, the answer will be 1. Then invert it, it will become 0. So this is the truth table of the NAND gate. This is the truth table for the NAND gate. Okay? Please better don't forget this. This comes in the paper. It's very simple. You only have to write the circuit symbol and the truth table. These tables are called truth table. Okay. Another, if you combine OR gate and the NOT gate, so that is called NOR. That is called NOR. N-O-R, NOR gate. It means OR gate and then in front of that you put a NOT gate. So its symbol can be written like this. It's like a spearhead. It has two inputs, A and B. They are fed to a NOT gate. And there you get the output. Okay? This can be represented with this kind of diagram also. This circle means invert. Okay? Its truth table is very easy. You have the input A, you have the input B. The X is equal to A plus B. Whatever will be the result of A plus B, you invert it. Okay, you understand? So the inputs can be 0, 0, 0, 1, 1, 0, 1, 1. 0 plus 0 will be 0 and invert it. 1 will be 1. 0 plus 1 is 1, invert it. 0. 1 plus 0 will be 1, inverted, it will be 0. 1 plus 1, 2, which is 1 actually, so inverted, that will be 0. So this is the truth table for the NOR gate. This is the truth table for the NOR gate. And in your paper, normally they ask you to draw these truth tables. So then he says uses of the logic gate. These are called logic gates, the truth tables. We can use the logic gates in electronic circuits to do useful tasks. These circuits usually use light depending resistors. LDRs are those resistors whose resistance is depending upon the amount of light falling on them. If the amount of light, for example, if the resistor is in the darkness, its resistance will be very high. When the resistor is in sunlight or in light, its resistance will low. So LDRs are those resistors whose resistance depend upon the light falling on them. If the amount of light falling on the resistor is less, its resistance will be very high. If the light is high, its resistance will be low. So we call them LDRs. These circuits usually use light depending resistors, LDRs, to keep inputs low, and LDR can act as a switch that is closed when illuminated by light or open in the dark. House safety alarm, we can use single NAND gate to make burglar alarm. That this can be done by using a NAND gate. An LDR, a push button switch S, and an alarm. Connect the LDR between NAND gate, input B. This diagram is in your book. If you are looking at your book, so that is easy. Input B and the positive terminal of the battery. The LDR will cause a high level input, that is 1 at the B, when in the light because of its low resistance. The LDR will cause a low level input O at B. When light is interrupted and causes high resistance in the LDR, a low level signal is also caused at A when burglar steps on switch S. So this burglar alarm sounds when either burglar interrupts light falling on the LDR or steps on the switch S. This diagram is given here in your book. If you want to see, you can see this book. Okay? We were talking about this. So if you pause it, you can also read it. Okay? So this is from here. We are talking about this thing. So ji, thank you very much ji. Have a good day. That's it for this chapter number 16. Only this topic is included. So ji.